Okay, and we would be dividing by s by the square root of n, like that. And so we would calculate 8.1 minus 9.02. So the numerator, just the numerator, 8.1 minus 9.02 is negative 0.92. So that's telling us that that our sample data, or the average of our sample, 8.1, is almost a whole unit below the claimed value of 9.02. So it's not exactly the same, but we wanted to determine how many standard deviations or standard errors we are from the claimed value 9.02. So that's why we divide by the standard error. So we would divide by 0.7 and root of 12. So it is 4.55, approximately 4.55 standard deviations, or standard errors, sorry, below the claimed value. Our sample data is. So the sample obviously is pretty significantly far away from our claimed value. So it's pretty obvious that we're going to be rejecting H naught. I can just tell right off. Hopefully you can see that too. A lot of us, that's a significant t-score. Oh, sorry, we're dealing with T naught, so it may not actually be. So actually, let's compare this to our critical value. That's where we need to do calculate our critical value at this point. So our critical value, so negative. Hopefully you can see negative 4.55 is not actually that significantly far when we're dealing with t-scores because we have fatter tails. So we need to check that. So our degrees of freedom in this case is 11. Remember, degrees of freedom is our sample size minus 1. So we'd look up 11 on our table, and then and that would tell us which row we're on. And then we would want to look up 0.01. Where are you? Right there. So I have a value of 2.718. Since we're doing a left tail, that would be a critical value of negative 2.718. Okay? So as we can see, this is significantly far away compared to the critical value. So as you can see, maybe a picture of this. A picture will help you determine how to what happens in step 4. But as we can see, our critical value, let's just say that's 0, and we're down here at negative 2.718. Negative 4.55 is in the critical region, on the tail. So that will tell us that we're going to be rejecting. It's always the same. Reject is on the tail, significantly far away from 0. In the middle is close to 0. That would be in the fail to reject region, at the FTR, fail to reject region. Okay? Reject H naught, fail to reject H naught. In this case, negative 4.55 is out here, further away from 0. So our test statistic is in the critical region. Okay? So we're rejecting H naught. Okay, so I'm going to leave it up to you to determine the p-value, and I'm going to make this example a little shorter, doing the p-value approach. But as we can see from step 4, that we are that our test statistic, for step 4, our test statistic, I'll put TS, is further away from the 0. In this case, since we're doing a left tail, our test statistic is smaller than our critical value. So we will be this implies that we reject H naught. Okay? We're rejecting H naught because the test statistic is on the tail compared to the critical value. Okay, so that tells us that how to word our step 5. So first off, remember the flow chart. Does the original claim contain the condition of equality? Since we're doing a left tail test, you should be able to see that that would be a no, because we have a less than. It's let's see here. So the second part of the flow chart, it says, do you reject H naught? That would be yes. We reject H naught. So the wording for this, I actually lost my page because I went to the T table. Let me pull this up really quick. We're in 10.3. And we were going over example. There we go. Effects on the brain, number 15. Okay, so here we go. We have a no and a yes. So we go down and then up. So we're on the third option of the wording. So the sample data supports the claim that the sample data supports the claim that, and then original claim. So we just copy and paste our original claim to make sure the sentence flows. So the sample data supports the claim that the hippocampal volumes, campal levels or not levels, who cares, volume in the alcoholic adolescents were less than the normal volume of 9.02 centimeters cubed. And then if you want at the alpha equals 0.01 level of significance. That is a solid conclusion. The sample data supports the claim that the hippocampal volumes in the alcoholic adolescents were less than the normal volume of 9.02 centimeters cubed at the alpha equals 0.01 level of significance. Okay. Hopefully you're getting this flow chart down, but I did the classical approach for this mean example. Go ahead and try to see if you can understand the p-value approach for rejecting H naught. And just to quickly show you the different tests that you would do using your TI-83, you can do this really quickly. You can go to stat, and then you go over to tests. And if you were to do a proportion problem, a hypothesis testing for proportion, we would go down to one prop for proportion and one representing one variable, z-test, since we're doing a hypothesis test on proportion, one variable. So for our previous example, we were doing a right tail test. So we would go to right tail greater than p naught, and our p naught value, if you remember from our previous example, our p naught was 0.019. And our x was 19, and our n was 863. Go ahead and check that example again, and we would calculate. Look at earlier in the video, and you'll see that those would be our values. And as you can see, we got the same. Actually, what happened? 863.019.258. Wait, where am I? Let me make sure I entered this in correctly. Test 1 prop z test 0.019. It's a greater than. So according to this, we get the following test statistic, 0.649. And I got 0.76. If you remember, I'll go back to this really quick. 0.76 in our calculation for our test statistic. And here we got 0.649. And let's just double check here. 19 divided by 843 minus 0.019. And then we divide. Let's go ahead and you can see this a little better. Oh well, I can see it. That's good enough. Second square root of 0.019 times 0.01 or 81 divide 863. 0.76. What is going on? The right tail does. It doesn't make a difference. 19 over 843. Why is this value so far off? So this is, yeah, I'm doing these live. That's okay. Not live, but just winging it. Why are we doing this? 0.019. That is correct. And 19 and 863. It's a right tail test, which should make a difference for test statistic. Calculate 0.649. We use. Am I actually disagreeing with the calculator? Because I feel like we are doing this correctly. 10.2. Maybe they're using a different calculation, which wouldn't make sense. Oh, they're using a calculation. This really isn't making sense to me. Why am I getting a different? I'm checking the book. Alright, let's check this one more time. I don't know what is going on here. Wow. I do not know what I did wrong, but now I'm getting the right answer. Okay. Apparently, well, not the right answer, but what they're getting in the calculator. I don't know what I did wrong before, but I'm getting 0.649. But it does not change our conclusion. We're still well into the fail to reject region. Sorry about that. I don't know what happened. Yeah. So that's 0.649. I'll put some remarks in the beginning of the video that fix or mentions that my mistake. So sorry about that. All right. So anyways, that really doesn't affect too much. Apparently I made a calculator error. I'm human. Oh well. All right. So if you have any questions, please let me know. These were two examples of hypothesis testing involving proportion and mean. So I'm going to make a new video, and so we're done reviewing chapters 8 through 10 from Math 243. I'm going to make a new video, separate video on standard deviations. We're going to be doing confidence intervals and hypothesis tests for standard deviation. So that will be new. You have not seen that in Math 243. So anyways, let me know if you have any questions.